What's up? Today I'm going to be showing you how to install Verilog and Emacs on your system so you too can start creating digital circuits. A few things before we get started. This tutorial is mostly going to be geared towards Windows. I will also show you how to install things on Linux, but I do not have a Mac, so I cannot show you how to do it on Mac. But with that in mind, let's go ahead and get started. The first thing you're going to want to do is come to the Verilog homepage if you want any information on Verilog or Verilog mode. But most of this is outdated. It does have links to GNU Emacs and Xmacs if that's what you wish to choose, but this whole register thing is not needed. Verilog mode is actually just built into Emacs when you download it. So you can either click on the GNU Emacs link here, and I believe that will I don't know why it wants to do that. I'm not going to let it do that. Go to the GNU.org, go to the GNU Emacs. You can just search that in Google and it will pop up. There are two other Emacs distributions you could install. There's Doom Emacs and Spacemacs. These are both just customizations on GNU Emacs with some additional things. If you are a big fan of Vim and the Vim key bindings, I believe these both support Vim key bindings, though you can also just install them onto GNU Emacs. I will be using this as my main editor for all of this because it's just the most simple and I don't want to have to get into all the other things in this tutorial. So for Linux, it's pretty simple. Just use your package manager, figure out which package manager you have, and install it that way. For my WSL virtual machine, I'm running Ubuntu, so that's the apt get install Emacs. There we go. So that's that. For Windows and Mac, you have to scroll down a bit. For Mac, I'm just going to show y'all right here. You need either Homebrew or Mac ports, and you will need that again later for the Verilog compiler. So make sure you have access to either Homebrew or Mac ports. Otherwise, things become a lot more complicated. The Homebrew website is a great website. I've used it for other things that weren't Mac. So just go here, follow the instructions, and you'll have that running in no time. Mac ports is macports.org. All the links for these will be in the description if you need them. And just read and follow the instructions. So back to the GNU webpage. For Windows, if you have MSys2, you can install it with Pacman as well. But if not, you need to click on one of these links and it should take you to this page. If you want to install the newest version of Emacs, that's Emacs 29. And then you just scroll down till you find the Emacs 29.2 installer.exe or whatever the current newest version is. Click on that and it will start the download. I've already done this, so I'm just going to cancel that and open the folder where it's installed. So once it's installed, you can click on the exe to run it. Let it do its thing and just follow the setup wizard. We'll give you the terms and agreements, ask you where you want to install it. You can change that if you so desire or just leave it as the default. And honestly, that might have messed up my other install, but we'll figure it out. Alright, and then it's going to ask you if you want to create a shortcut, and then you can just close to finish. So let me go ahead and open up Emacs. And there it is. So hopefully by this point you have managed to get Emacs installed on your system and have opened it to be greeted by this page. real quick before we continue, I am going to open up another window here so that I can display the hotkeys that I will be using throughout this tutorial. If you want, you can still do things like open files and save files with these buttons up here, much like most text editors. I'm going to be using the keyboard. So over on this page, if you want to, you can read through the Emacs tutorial. It's going to have a lot of useful information for you, and it's not even going to take you out of Emacs. Just some simple stuff. The capital C dash, it means the control key, and the capital M is the meta key. If you are on Mac, your meta key might be either command or options. It depends on your setup of your system. So if you ever hear me say meta X, that's Alt X on Windows and Linux, and command or options on Mac. You can also customize, open a file. So this is a nice screen if you're new to Emacs. I've used it enough where I turn it off eventually. But let's say you open the screen and you just don't like white backgrounds. Something you can do is you can type, oh, my other buffer's gone. Where did it go? There it is. You can type meta X and then customize theme. We'll open up this page and you can just select a color theme you want and go with that. And then hit Q to quit. And you'll be brought back to this window. And to me, that just looks nicer. So the next thing we need to do is figure out how to open a file that we can use, or we can do Verilog in. How do we open and use Verilog mode? Well, that's Control X F is going to be find a file, and then from there your cursor actually comes down here. This is called the mini buffer, and it's where you'll input a lot of commands. You can come down here and you can type the path you want. We're just going to make a new folder, Verilog, and then call this the half adder. Now it says down here and over here on the side it says use meta X make directory return to create the directory and its parents. That's because we asked it to put a file somewhere that doesn't exist. So all you have to do is that exact thing, meta X make directory, enter, and it's been made. So now we have a Verilog file, and we're actually in Verilog mode, and you can test that by typing module, and you'll see you get your syntax highlighting. Right? And you get your automatic indentions and a lot of things like that. And that is how you access Verilog mode. Alright, now that we're in Verilog mode, let's see about writing a half adder. So what we're going to need for a half adder is we're going to need the sum, the carry, and then two inputs. Let's call them X and Y. And then the way I do it is I also have another output. We'll just call it O for output, where we combine the registers. Your outputs is going to be S, C. Your reg for your out is going to be 2 bits, 1 and 0. Oh, I didn't name it. Remember to give it a name. then your inputs X and Y. So then say you set up some basic data types, and then after that we just set up the gates. So we and for the carry we and X and Y, and we XOR for the sum of X and Y. And now we have those two bits. So what we're going to do is we're going to assign the most significant bit of our out variable to C, I believe. Yes, if I'm thinking of this right. And we're going to assign the least significant bit to the sum and in the module. And you'll notice it immediately added the comment of what module we're closing. That is a part of the Verilog mode, which is built in. And now we need another module, our test bench. It's not going to take any parameters. We are going to create true registers A and B. These are going to be our inputs. We're going to have we need wires for the outputs that we're passing in, and we're just going to call those sum and carry. And then we need, if you're doing system Verilog, you can do this for our control loop. If not, you need to make a register and set it to the appropriate size. And then we are going to do a register for the output of 2 bits once again. And I didn't name it. So once you've done that, you call your module, pass everything in, and then you do the keyword initial. And that's how and then you're going to put the code you want to execute inside of this. And I am going to want to do a display. This is how you output stuff. And we're going to output, let's just make a little truth table, A, B, S, C, and then we'll call it the O for out. We'll just call it that. And let's call it T for total. Right, that makes a bit more sense. And then for I equals 0, I less than or equal to 3, I equals I plus 1, begin. And then in here, what we're going to do is we're going to take A, I divided by 2 mod 2. And then B is equal to I divided by 1 mod 2. I believe that's correct. You need a time delay. I am just going to do #8, and then we're going to do a display. This is just so everything has a chance to get caught up. I did not spell display right at all. And now we're going to do %d, %d, I'll cover all those. Oh, whoops. And then you gotta label them out. So we need to print out a comma b comma s comma sum comma carry comma. Yeah, I think that's right. And then hit it with another delay. I'm not sure if that delay is actually required. And then a finish for the initial. Then another end. And then end module. Cool. So if I did all of this right, this should work as a half adder and print out its truth table. To save, you hit Control X, Control S. And now we need to find a way to run our code. So what I'm going to do is I'm going to jump over to this other screen with Control XO. I'm going to split it in half with Control X2. And then I'm going to hit Meta X, type in E shell. And that loads up a shell, a terminal. There it is. There's our file we just made. And the compiler for Verilog is called iVerilog. There might be others out there. That is the one I am using, and it works great. It compiles both Verilog and System Verilog. So let's go in here and go iVerilog, like that. And you'll see command not found. That is because we have not installed that. So let's hop back over to the web browser and see about installing it. Alright, so we're back over here on the web, and I've looked up iVerilog, much like you can do, just to easily find these links. These are the two links I have been using, but if you're on Mac, you install it much like you do for Linux, except you use Homebrew or Mac ports. So if you're on Linux, it's really easy. You go to your package manager, you just do, if I could spell. And it will install it. There we go. And then for Windows, you can come to the GitHub page and install it. I think they do kind of give you a way to do it on Windows, but I would recommend coming here. Someone has created the executable you need. If you're on a 64-bit system, this executable right here. I guess version 12 is the newest one right here. Oh, that's not an exe though. Just do this one. It's the one I've been using. It's been working fine. Download the newest executable, and that will start the download. I already have it installed right here. So if I click that, yes, I want it to make changes to my system. Yes, I agree to the GNU General Public License. I have so many times before. Okay, so this is important. This is pretty important. Basically, if your path is weird, it might not install properly. I'm just going to install it at where it wants me to. You can do install GTK Wave if you want. That allows for actual simulation and visualization of the circuits you create. Might as well just go ahead and do that. And then this is the most important thing right here. When you get to select additional task, make sure you click add executable folders to the user's path. Otherwise, you have to go in, you have to find where it's installed, you have to add it to the path yourself. Nah, skip that mess. Just click the button. All right, the Linux one is done. All right, and that should be installed. So if I come here and I type Verilog again, command still not found. You might have to restart Emacs, so let me do that and I'll be right back. All right, we're back. And as you can see, just a simple restart allows me to now see that the Verilog command is found. It's just telling me no source files because I didn't feed it any file. So what I'm going to do is I'm just going to type Verilog -G. What this is going to do is allow me to give it a year. 2012 is the year you're going to want to give it if you want to use system Verilog. You can find these, it's shown right here, G-1995. They're basically the IEEE standards that they were following at the time. And then you can do -O, give it a name. Just call it half adder, like that. And then the name of the file. And then you can hit enter. And I got 2 errors. So I'm going to fix those. And I am going to be right back. Okay, so the problem was right here. It looks like I didn't name this. Before it was just half adder. I think you need to give it a name. That's what this is saying on line 18. You can tell what line you're on down here. Line 18, it said I did not have an instance name. So let's resave this file with Control XS, Control XO back to the shell. Run that again. And more errors. So we'll be back in a second. Okay, so we're back. I found the problem. It was up here. I can't declare O as a register like I had it. It has to have what they call, I guess, direction, which is an input or an output. So I just made it an output. And as you can see, if we come back over here and compile it, compiles that time just fine. Now the fun part here is on Windows. On Linux, I've been every time able to just to run it Verilog like this, compile it, and then // the name you gave it. But in this case on Windows, depending on your system, I'm not sure why. Sometimes you can't run it this way, other times you can. I'd recommend trying it this way, and if it doesn't work, the next thing to try is VVP half adder, the name of the file, and then that runs it. And as you can see here, we get a little truth table out. 0 plus 0 would be 0, 0 plus 1 is 1, 0 plus 1 is 1, 1 plus 1 is 2. So I put these in the wrong order, but this would be a half adder. And that's how you can run and compile code in Emacs for Verilog. I hope y'all found this helpful.